Previously, we have seen how this H1 cohomology of OX star classifies invertible sheaves and also classify line bundles. To each line bundle or to each invertible sheaf, we can associate the co-cycle corresponding to the gluing data, i.e. the transition functions. So both of these, so there is a more general principle underlying this. Both of these are locally trivial objects. Right, invertible sheaves locally are just O. These are locally isomorphic to the sheaf OX, and line bundles are locally isomorphic to the trivial line bundle. Each of these objects has a trivialization, local trivialization, as the following, and we want to associate to it the cycle corresponding to these transition functions, which we can think of, for example, in the case of line bundle, as a change of coordinate. Observe, for example, in the case of line bundle, this Tij should be a invertible map, a linear isomorphism from C to C, right? An automorphism of C. And in this case here, this Tij must be an automorphism of OUij. So these transition functions, they lie inside, they are elements of the automorphisms of these trivial objects. So the general principle is as follows. We have some notion of trivial object. Generally, the isomorphism classes of locally trivial objects are going to be in one-to-one correspondence with the H1 cohomology with coefficient in the automorphism sheaf of the trivial object. In the specific case we were looking at for line bundles, the automorphism of the trivial line bundle and the automorphism of the trivial invertible sheaf, which is O. Both of these are isomorphic to the sheaf O star. So now let's see why. Now let's see why the automorphism sheaves for line bundle is O star. So what is the section of the automorphism sheaf of a trivial line bundle? Right? On an open set U, that would be automorphism of C times U to C times U. And what does that look like? That should be, well, it should sense each fiber to each fiber, right? So it should be an automorphism on each fiber. So this automorphism then, but on each fiber though, the automorphism of each fiber is automorphism of C, and that's just going to be given by multiplication by some non-zero numbers. So this general automorphism, when you take it at any p, that corresponds to a non-zero number. So this map F, this automorphism, is just a regular function in O star. Similarly, let's look at automorphism of the trivial invertible sheaf. Its section on any U should be an automorphism of OU as an OU module, so that would correspond to multiplication by some non-zero element. That's why the sections would be sections of O star.